Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When HCN adds to an achiral carbonyl compound, acetaldehyde, CH3ChO, the nucleophile, CN- can attack either face of the planar carbonyl carbon with equal probability. This is because the carbonyl carbon in CH3ChO is sp2 hybridized and has no pre-existing chirality, so both the re phase and C phase are attacked with equal likelihood. The transition states are mirror images of each other and have equal energy. Step 1. CH3ChO is achiral, no stereocenter. The carbonyl carbon is planar, sp2. Step 2. HCN adds via nucleophilic addition. CN attacks the carbonyl carbon. Since both faces of the carbonyl are equally accessible, no chiral influence, CN attacks from the top face and bottom face with exactly 50% probability each, producing equal amounts of R and S cyanohydrin. Step 3. Hydrolysis of the nitrile, CN, group with H2O, HO, converts CN to CoO without breaking or inverting the bond at the stereocenter. So the stereochemical ratio is preserved. Step 4. The product CH3CH, or CoO is lactic acid, which has one stereocenter. The reaction produces equal amounts of D and a lactic acid, i.e., a racemic mixture, 50% D plus 50% L. Why other options fail? A. The isomer only would require selective attack on one face, which does not occur with an achiral substrate and achiral reagent. B. L isomer only, same reasoning as above. C. 80% D plus 20% L, an unequal mixture would require some chiral influence, asymmetric induction, which is absent here. Therefore, the correct answer is D. Therefore, the correct answer is option D.